Hi guys, welcome to my YouTube channel. We have talked about the memorizing the periodic table, and we talked about how do we go about it in three different sequence or weeks, actually a 2 week period. So you do it on a bi-weekly manner. So you go about 10%, or I think around 14% for the first time, and then you expand it to more elements to contain actually 30 or 32 something element, and then 50 60 I believe 60 element that would constitute something like 50% of the periodic table. So let's go back to the periodic table one more time, and today I want to talk about cations and anions. Okay, so not only the elements are important, but electrons are the main players in chemistry. So when you do know about lithium, for example, you should know that actually how would it actually behave chemically, and that means does it want to lose electrons or gain electrons. So main elements are those that we should know of, and group 1 element and group 2 elements tends to lose electrons. So they lose 1 electrons, and since they have one in their how to say valence layer, as we actually know. So this is like, if I go here on the top with starting with lithium, let me use a small marker, so I could do the small beryllium, then they have the gap, then boron, carbon, nitrogen, oxygen, fluorine, and xenon. Okay, so they have one. Group 2 has two single reacting electrons, boron 3, carbon 4, nitrogen a lone pair, and then 3 single reacting electrons, oxygen 2 lone pair and 2 single reacting electrons, fluorine and chlorine 3 lone pair and 1 single reacting electron, and something like xenon, neon, argon, just a set of 4 lone pairs that makes 8. Okay, so that's why noble gases are noble. They are reluctant to react. These we call Lewis dot structures, and we also talked about them when we did Lewis structures of molecules. So starting from the first group, as you know, we move on, we add 1 electron, but the electrons are going to sit in 4 different spaces. We've not talked about orbitals yet. You could kind of assume that there are 4 of those orbitals around each element, right from group 1 to group 8. And as you go, you continue adding 1 electron in these spaces until you reach carbon. In it, all these 4 spaces are filled with 1 electron, and in nitrogen, the extra electron is going in that first spot, making it a lone pair. Okay, for oxygen there are 2 lone pair and 2 single reacting electrons. For fluorine there are 3 lone pairs, and for xenon there are 4 of them. Okay, so when you look at the reactivity, these wants to lose 2 electron or 1 electron. So group 1 and 2 and also 3, they want to lose 1 electron, 2 electrons, and rarely, actually this one is mostly, aluminum is the one that actually loses 3 electrons, okay, to make something that is Al3+, that is the aluminum cation. Okay, and for naming main element cations, we just follow the name cation after them. So lithium, sodium, potassium, rubidium, cesium, francium, beryllium, magnesium, calcium, strontium, barium, rhodium, cations, or we just say them by name, and we say when we write them, for example, the magnesium cation would just be Mg double plus, because group 2 elements just lose 2 electrons. And if you move to this carbon thing, carbon group 4, they don't usually make anions or cations, and from group 5 all the way to group 7, they tend to gain 1 extra electron because it's easier for them. For nitrogen, if it just gains 3 more extra electrons, it would have 8 electrons in its valence shell. For oxygen, it needs only 2 more, and for fluorine, it just needs 1. Xenon, neons, argon, and or null gases, they don't need extra electrons, so they don't form anions or cations. They're just noble. Okay, they have their enough electrons in their valence shell. So fluorines, they would actually F minus. And for these, we just say whatever the name, we just replace the ion or the final part of it, whatever it is, that final letter, with IED. For fullerene, chlorine, bromine, iodine, if I just show you, F minus, Cl minus, Br minus, and I minus would be fulleride, chloride, bromide, and iodide, instead of the element that has INE, the anion, which is actually after adding one electron, so that would be F minus, Br minus, Cl minus, I minus. We would just say fulleride, chloride, like that. For this, it would be two minuses. O double minus would be oxide instead of oxygen. That final part is replaced with I. And sulfide. Also for this, it would be nitrite and phosphide. We rarely actually have phosphide, but if you have ever P3 minus, that is called phosphide, okay, instead of the element, compared to the element that is phosphorus, okay. Some of the anions that we know of are polyatomic, okay, those ones that we actually did Lewis structures for, and we need to memorize the famous ones, okay. There is a list of 7 of them that are crucial, you need to memorize, and as you memorize each of those 7, there are related anions that you could actually memorize. Now I would like to go through those 7 main anions that you need to know of based on their charges, okay. They are again polyatomics, so I'm going to write them down. The ClO3 minus, it is called chlorate. NO3 minus, which is called nitrate. CO3 double minus, which is doubly charged, it's called carbonate. SO4 double minus, it's called sulfate. PO4 triple minus, it's called phosphate. And acetate, ACO minus, and the formula is CH3COOO minus, okay, or you could say CQH3CO2 minus. That's the close formula, that's the structure. The abbreviation is one I prefer, and that's AC, that stands for acetic or acetate. That is this part of the molecule, okay. The ACO minus, O minus means it's the anion. If you add a proton, it would have the acid, that would be the acetic acid, okay. Now let's move on to the important part of information in any polyatomic ion. This means that I have 1 nitrogen, 3 oxygens, and an overall charge of -1. And we also noticed when we did Lewis structure, we have 3 oxygens, 1 of them being an O negative. The same exact case here. There are 3 oxygens, 1 carbon, and a total charge of double minus. Same thing here, same thing here, same thing here. So you should know the formula and the names. When you do know nitrate, okay, this one is nitrate. If you get 1 less oxygen, you kind of have an ith version of it. So if you know nitrate, that is NO3 minus, you kind of know at the same time NO2 minus. Now the charge doesn't change, just the number of oxygens become 1 less, and the 8 goes to ith. So nitrate, nitrite. Also here, that's not applicable to this one here. It would be instead of sulfate, it would be sulfite, okay. So ith again, sulfite. And for this one, we don't have that aspect. For this is chlorate. The strange thing about this, let me just use another color. Let me just get rid of the acetate for a second and talk about this. It could have one that has 1 more oxygen. We have a ClO4 minus. The ClO3 minus is called chlorate. We could have ClO2 minus and ClO minus. Okay, so there is 8. This one is 1 less, so we could just go say this is ith. We have 1 extra and 1 also, like, we have two extreme cases with one more extra oxygen and with one more extra less oxygen. This one we call hypochlorite, and this guy we call per. So we add a per. Colo, again, like the one that here, it's 8 again. So just this per thing for chlorite, this per suffix and this hypo suffix is actually being added to the prefix are being added to the versions that have one extra less and one extra more oxygen. Okay, also you could add protons to this and you would still have anions that we are interested to know their names, but it would be simple. Okay, let me just go about those that have kind of protons added to them. Okay, so the versions that you could add protons are multiple charges. You would have steel anions, because the versions that has just one negative charge, if you add one proton, they would be acid versions, and we will talk about that real quick. But first let's talk about this. So CO3 minus, if you add one proton, it's adding H3O, H plus and CO3 double minus. It would give you HCO3. Now you just change the charge when you attach them, okay? +1 minus 2 would be -1. So that's the only thing that changes when you add protons, okay? The plus charge here with the doubly negative charge becomes -1 here, okay? So that's the only thing, and we call it bicarbonate. We have carbonate and we have bicarbonate if you have hydrogen, or you could also say hydrogen carbonate, bicarbonate or hydrogen carbonate. So another anion related to this is HCO3 minus, that's bicarbonate. If you add one more proton, you get the acid, we call it carbonic acid, H2CO3. This 8th thing that you have here becomes ic, and you also add acid to it. Okay, so the 8th goes to IC, carbonate, carbonic, carbonate anion, the carbonic acid. Okay, let's also talk about the sulfate case. You have SO4 double minus. If you add one proton, it would be hydrogen sulfate or bisulfate. Okay, if you add Q, you will get sulfuric acid. Also, if you talk about PO4 triple minus, if you add one proton, HPO4 double minus is called hydrogen phosphate, and we could also have bihydrogen or dihydrogen phosphate. That is this. And if you add a third proton, that would actually cancel all the 3 negative charges, and it's phosphoric acid, H3PO4. Okay, now let's talk about the cases where we have the chlorates, just one. This cases where we have one negative charge, that's very simple actually, but let's just go through that because we want to cover all those names. For ClO4 minus, if you add one H, that would be perchloric acid. Okay, if you have BrO3 minus, that's boromate, and HBrO3 would be bromic acid. Okay, so perchloric acid but bromic acid, because this is a perchlorate but this is a boromate. IO2 minus, that is iodide, so IO2, HiO2 would be iodus. So this one is different. If you have the ite, when you go to acid, it becomes OUS. Okay, so this becomes iodose acid. Also for the ClO minus, if you have HClO, that would be hypochlorous acid. So that's how you name it, hypochlorous. Hypo because there's only one oxygen, and chlorous because this is actually hypochlorite. Okay, it's the ClO minus. For NO3 minus and NO2 minus, NO3 minus and NO2 minus. You have nitric acid, and you have nitrous acid, because this is nitrite. Remember, 8 becomes ic and 8 becomes OUS, so nitrous acid, and nit compared to nitric acid. Okay, also there's one more ion that you need to know, and that's Cn minus. We call it cyanide, and when you add one proton it becomes cyanic acid. This is, by the way, cyanide. Okay, so if I just write it down, that would be cyanide. Like that. Cyanide acid, cyanide ion, and cyanic acid. Okay, so that's how you write that down. And then this is, I believe, all those anions that you need to know. Now there are 7 of them that are crucial, and that's, again, I'm going to write it down one more time real quick, because based on those and those suffixes and prefixes that we talk about, you could just know what kind of things. ACO minus, that is acetate, and if you actually add proton, that would be acetic acid. CN minus, NO3 minus, my bad, CO3 double minus, carbonate, nitrate, SO4 double minus, sulfate, and PO4 triple minus, phosphate, I believe, and also ClO3 minus. And for this one, if you do it for with chlorine, boron, or iodine, and you just, the first part of the name would just change. So this would be a chlorate, a BrO3 minus would be a boromate, and an IO3 minus would be an iodate. So just the first part changes. 1, 2, 3, 4, 5, 6, 7. With this 7, you know all those anions that we talked about, okay, and how you add protons to get different kind of hydrogen hydrogen phosphate, or hydrogen sulfate, or bicarbonate or bisulfate, or those kind of things. For the cations, there are a number of cations that you need also to know about. One of the most important of the cations that you need to know about is ammonium, NH4 plus. That's the only polyatomic cation that you ever encounter. There's one more tricky one that we will talk about, but this one is the only one that is like other 2 different elements, hydrogen and nitrogen, like the anions, polyatomic anions that have several atoms connected together to making cation, to make an anion. For cation, that's the only example, and we will have one more that has the same elements actually joining together. So it's not rather that kind of polyatomic, because there's just one single element. So most of those metals that are cations, like lithium or sodium, we would just call the same name for the elements, for the metals, like these main group metals. And for this we had that IDE password, my bad, IDE suffix that you add. Okay, so nitride would be N3 minus, or phosphide would be P3 minus, S double minus would be sulfide. Okay, those are the ones that we kind of know without any memorization. Okay, so we know these are the same thing that they call the element, we call the cations, and this just has a IDE suffix that we add. For the transition metals, there are some of them that I need to mention, and you need to actually go about and learn. One of them is chromium here, the other one is Fe, and the other one is cobalt. So these guys, chromium, Fe, and cobalt, let me just write them down here. They kind of have +2, +3 charges. So you could have Fe double plus, Fe triple plus, cobalt double plus, cobalt triple plus, or chromium double plus, chromium triple plus. Below column 11 and 12, which is group 9 and D9 and D10. Okay, these column 9 and column 10, because there are 10 columns of transition metals. For column 9 and column 10, if you need to know this one, Ag, you need to know also this one, which is Hg. Okay. Oh, my bad. Not Ag. The Cu, copper. You need to know copper and mercury, these two. And they are only going to be either +1 or +2. Okay, so that there's another thing that you need to know, +1, +2 group. And by the way, 1 in chemistry, we never write it for cation. So I don't say +1 here, I just say plus. Okay, so plus or +2, that's only for these two that you need to memorize. Copper +1, copper +2, Hg, Hg +2. That's the example of Hg plus. It's going to appear as attached together. So two of those Hg plus ones attached together to give you this kind of species, along with NH4 plus. These are the only ones that have more than one atom in a cation. Okay, we don't get a cation that has more than one atom anywhere else other than these two, at least for a general chemistry class that we are talking about. Okay, and then there is two other ones here, Sn and Pb. They are group 4, but they are kind of strange because they have a kind of metallic character to them. They could produce double plus or 4 plus cations. Okay, so you could have Sn double plus, Sn 4 plus, Pb double plus, Pb 4 plus. So +2 and a +4. So there's only 3 trends that you have to memorize actually. +2 and +3s, plus and +2s, and +2 and +4s. And as you look, you move on from this part of the periodic table to these two columns, more to the left to these two. Okay, so Fe, chromium double plus, chromium double triple plus, Fe double plus, Fe triple plus, cobalt double plus, cobalt triple plus. Then you move to the middle section with +1, +2, where you have copper plus and copper double plus, and Hg double plus and Hg2 double plus, which is actually the same as Hg plus species. It just appears like this chemically. And these guys, you move to the more to the left and more to the right to actually use to Sn and Pb, that is double plus and 4 plus. So it could be two other cations. How do you know them? You have to look at your ionic compound. Okay, and how do we name them for the minimum charge? For example, here for +2, we say OUS, so ferrous, cobaltous, chromos. Okay, for the maximum charge, we say IC, so mercuric and also cupric. Okay, and also here cobaltic, ferric, and chromic. Maximum charges IC, minimum charges OUS. The same exact rules for here. OUS for the minimum, which is double plus, and IC for I apologize for this. And IC for maximum charge, which is +4. Okay, so for +4 you say IC. This lead, we call it plum, so we say plumic plumose. Plumbose is Pb with minimal charge, Pb double plus, Pb +4 would be plumic. And Sn, which is tin, we call it estan, estanos for Sn double plus, and estanic for the maximum charge, which is 4 plus, estanic, estanos. So these are the cations, and those are the trends we need to memorize. I would just like to do real quick some naming of ionic compounds so that we can get wrap up. You need to know two sorts of things. If I gave you the formula, you should be able to write down the name. If I gave you the name, you should be able to write down the formula. Let's just do the first one, the second one first, when you have the name and you want to work out the formula. Ferrous, and the name of the cation always goes first, as in the formula. The cation's formula goes first, followed by the name of the anion, and in the formula by the symbol of the anion. Okay, ferrous phosphate. Mercurous nitrate. Ammonium hypochlorite. chloride. Let me just have a little space here, and sodium boromate. Those are the ones that I want to talk about the formula as well. So ferrous, I know that Fe is in the group here that have a +2 and +3. Okay, so I just need to know their location. +2, +3 is here, +1, +2 is here, and +4, +2 is here. So if you have ferrous, it with the minimal charge, it means between a +2 and a +3, you're going to choose the +2. So this is Fe plus double plus. And phosphate, you should know this, you should memorize this. Okay, when you're going to write down the ionic compound, you put the formula for the cation followed by the anion, and then you swap the charges. So the charge for the Fe is +2. I just put in parentheses a 2 for the phosphate, because there are 2 phosphate, so both P and O4 should be 2 of them. That's what I do in parentheses. For Fe, there are 3 here. That's the formula. And why I do that, I can show you that now the charges are going to cancel out when you swap. How many Fe do I have here? 3. 3 and the charge is +2. So 3 + 2 is +6 here. What is the charge of my phosphate? 3 minus. If I have 2 of them, that would be -6. Those cancel out. Okay. In ionic compounds, we don't write the charges, so we just compute how the charges should cancel out, because ionic compounds doesn't have any net charge. Okay. Let's talk about this one. Mercrose is Hg. Hg is going to have just one plus charge and double plus charge. For the minimum, it's going to be +1, but that was the exception. That guy was like Hg2 double plus. Okay, it was 2 connected to one another. So that's the cation. So I just do Hg2, and I know the charge is +2. And NO3 is nitrate. NO3 minus. The charge of NO3 is 1. So nothing here, Hg2, so I don't need a parentheses or any other number than Hg2. And this Hg2 comes from the formula for the mercrose itself. The charge for it is double plus, so my nitrate needs a parenthesis and a 2 here. So Hg2 NO3 in a parenthesis 2. Ammonium hypochlorite. Hypochlorite is ClO minus. Ammonium is NH4 plus, and I do NH4 ClO. And if you have same charges, no matter what, if it's +3 or and -3, or +4 and -4, or +2 and -2, or like here +1 and -1, it's just going to cancel out, so you don't need to do anything. You just write them down in sequence of cation, and then followed by the anion, and that's it. Sodium boromate, again Na plus and BrO3 minus, that's boromate. And NaBrO3, that's the formula, because the charges are again the exact same charge. Let's go to do a reverse example of this, where I gave you the formula and I want you to name it. Okay, I'm not going to write the name down, but I'm going to hint about the parentheses, but the prefixes, okay, because it's going to be a little bit sooner. This one, Hg, H2PO4 double minus, chromium, HCO3 3, and NH4 SO4. Now Hg, I don't know what the charge of this guy is, but I know the charge of this one is -1, and if there's 2 of them, it's -2, so this guy should be Hg double plus. Hg and Cu again are in this part where they can have minimal charge of +1 or a charge of +2. Okay, this guy has a +2, so it's called mercuric, and we call it mercuric bihydrogen phosphate. okay, or dihydrogen phosphate. So mercuric bihydrogen phosphate is the name for this one. This guy, carbonate, we know carbonate is CO3 double minus. We also know that if add one proton, H3O minus would be bicarbonate, just one negative. If there are three of them, they make 3 minus, so this chromium should be plus 3. And chromium again are among these families at the very left that can have plus 2 and plus 3 charges. So if they have plus 3, that's the maximal charge possible for them, and it's going to be chromic. So chromic bicarbonate. And for this one, it's just ammonium, and this guy is sulfate. I know both of them for just ammonium sulfate. I'm going to wrap it up here, and we will actually return when we have another topic to talk about.